Good evening, ladies and gentlemen. Today we are going to start our webinar on telecommunication technologies. So we have started our discussion on telecommunication technologies a couple of weeks ago. This will be our third lecture that we started from 5G technology and we discussed about generative AI. And today we are going to have a broader discussion on the development of telecommunication technologies and its business model and how the operators can use the benefit of telecommunication technologies for the betterment of consumers and whole public. So we have invited a veteran person, an expert in the field of telecommunication. He's well-known person in this field. He's none other than engineer Anurad Udunuvara. I think he's well-known as Anu in field and in the industry. So on behalf of Electrical, Electronic and Telecommunication Engineering Section Committee, I am very much privileged to welcome you in this forum. So I'm very much sure that we can get maximum benefit out of this session because our resource person is having an eminent knowledge and experience in the field of telecommunication. So before I hand over this forum to him, I would like to introduce him to the forum. So Engineer Anurad Udunuvara is an expert in the field of telecom and technology and currently working as a senior engineer in Sri Lanka Telecom. He has over 20 years of industry experience in strategy, architecture, engineering, design, planning, implementation, maintenance of CSP and DSP network, and solution design. He is actively involved in the strategy formulation of his company's digital transformation, softwareization, such as SDN, NFV, cloud, SD-WAN, and research and development. He's a multi-award winning MEF, SDN-WAN Elite, SME, MEF Network Expert, and MEF SD-WAN Certified Professional. Anuradha is also a regularly invited speaker at many international conferences. He holds BSc Engineering in Telecommunication, and he is an ITIL and a senior member of IEEE and a fellow of IET and a fellow of British Computer Science Society. So without taking much time, I would like to hand over the floor to him. So we are very much grateful and honored to have you in this session. Over to you, Engineer Anurad Udunuvara.
Thank you very much for the introduction. I hope everyone can hear me correctly. Let me share my slides. Can you all see my slides?
Yes, we can see you.
Right, good. So today we are going to talk about the future of telecommunications, and it's in fact is a vast subject area, but let's look at specifically how we can navigate these techno-business advancements. It's not about just technology, but I would rather blend technology with the business advancements and how this industry has been progressing over the last 170 years. And as it was mentioned, like delivering the benefits to a larger cross-section of the mankind. So if you look at the history of technology, not necessarily the history of the mankind, but the history of technology, it would look something like this. And we live today somewhere here. So 2024 is somewhere here, and for many or some of us, our lifetime will span somewhere around like 2050 or something like that. So one of the questions at this very stage the people are asking is about human level artificial intelligence. Artificial intelligence has been one of the key topics that has been discussed in multiple conferences around the globe, even the Mobile World Congress in Spain. So that is one of the big topics in this part of our history, and that is also going to be one of the game-changing advancements even in telecoms. But this whole idea of technology advancements, not necessarily telecommunication, but the technology in the broader sense started in the 18th century, starting of the 18th century, and it's progressing in a kind of an exponential fashion. So within that technology advancement, at some point, we identify this idea of communication for the purpose of the audience who are coming from different backgrounds and at different stages of their undergraduate, postgraduate, or their career development. I thought of bringing in the idea of communication at very basic sense, which really means the process that allows information to pass between a sender and a receiver. Or it could also mean transfer of meaningful information between two locations. So that is basically where the word communication comes from. But if you take the word telecommunications, the tele means far off or distant. And again, the idea of communicating between two distant locations. So basically, today's telecommunication means the use of electromagnetic means. I will get back to that later on, to make communication possible over a distance. One of the good things about telecommunications is that although this history goes back around 170 years, the word telecommunications, as it was used 170 years ago, is still being used in this industry. There has been multiple changes, multiple revolutions, transformations that has taken place over the last several years, specifically during the last 30 years. But still we see the word telecommunications is being used in conferences. For example, if you happen to fill an online form, a survey or something like that, and I think you have come across that if you want to select the industry, there are drop-down menus, and telecommunications industry is one of the industries that is still recognized within the other industries. So that is about telecommunications. And as I mentioned, since this today's audience, I believe, is coming from electrical, electronic, and telecommunication background, at least the majority of them. What we basically do in terms of telecommunication is actually to use three types of media. One is electrical conductors, basically copper wires or wireless, and optical fiber. Copper and optical fiber are referred to as guided media, whereas wireless is unguided. In these three media, if you really go back to the definition of telecommunication or communication, there's a sender and a receiver, or A end or B end, or two ends. And in a copper wire, you generally see an electrical signal being sent from one location to the other, and this electrical signal is actually carrying the information which is supposed to transferred from one end to the other end. And on the wireless side, of course, you cannot see anything, but we use the environment or the medium to transfer a radio frequency signal from one location to the other location. And we use that radio frequency signal to actually transfer information from A to B. And on the optical fiber communication, which is the most used communication media today, uses a light signal which actually carries your information. So an electrical signal, radio frequency, and light signal is being used or are being used to send information from one location to the other. But the common thing in these three scenarios is that all of them use an electromagnetic wave being sent from one location to the other. So it's this electromagnetic wave propagation that actually results the information being carried from one location to the other. So after some time, we get to hear another phrase, which is called data communication. So this actually starts from the introduction of the computers, the internet, and this whole idea of data, which also goes hand in hand with the word digital. The bits and bytes, ones and zeros, which are more associated with computers and the IT world. And to facilitate that type of communication, we started the data communication. So it's basically a subset of telecommunications. Although all these signals, when you say an electromagnetic wave, you know that it is an analog waveform. The idea of data communication, although it might use, or rather it actually uses an analog wave, the help of an analog wave in the form of an electromagnetic wave in their basic transfer of the signal, data communication is actually considered non-analog. So it is called digital communication. So if you really look at the timelines of the telecommunication, it actually goes back to the years of something like 1837, where the telegraph was first introduced, the Morse codes and the stuff like that. So then came the telephone in 1876, and if you take the history of telecommunication in the United States, EE&T was established in 1885. The reason why the Americans is because the Bell Labs and the EE&T were, they are considered the birthplace of telecommunication business as such in the world. EE&T stands for American Telegraph and Telephone Company. So that also, even to date, they have not changed the name. So it really carries the historical value of the telegraph in communication and also telephone in communication. And it goes on, like we have the radio, and then the various legislations like FCC in US, the Communications Act, for example, Telecommunication Act in Sri Lanka, you can relate to that. Then microwave radios, transistors, the laser, which is being used for optical communication, the satellite, they started emerging in the 1950s. And then came the initial flavors of the internet, which is ARPANET, and optical fiber was discovered in 1970. Then cellular communication started in early 1970s or late 1970s, World Wide Web in 1990, etc. So this is a very high level history of telecommunications up to the 1990s. And at the same time, around 1960s started another timeline. Why it is important is that the telecommunication timeline, if you really carefully look at, and the internet timeline actually start merging somewhere around 1990s. And that is why we have something called a telecommunication and also data communication. And these two businesses, if you take it in the business sense, we see it start merging in around 1990s. And it has been the case not only in US, but in our parts of the world as well. So the computers, the internet, data communication, things associated with the data communications, the World Wide Web, DNS, etc., started emerging. So this is actually a kind of timeline for the telecommunication history in Sri Lanka. You can see it actually matches with the telecommunication history in the world as well. So being a Sri Lankan, and also we all being Sri Lankans, one of the good things that we all can be really proud of as engineers specifically is that we have been always gone in parallel with all the technological advancements in the phase of telecommunications in the world. So, for example, when the Europe introduced ADSL as a technology, we introduced it here in Sri Lanka. And when the Western world introduced fiber to the home type of technology, we introduced that in Sri Lanka. When the world introduced 5G as a technology, we introduced that at least at test level in Sri Lanka. So we have several other things to boast about in terms of being the first in Asia, being the first in South Asia in introducing multiple technologies. But the real highlight here is that an industry which is almost 170 years old started very slowly and in today's terms using very primitive technologies. But when you pass the year 1990, it actually started accelerating because of this combination of telecommunication and data communication. So we are at a point today that we actually cannot distinguish telecommunication from data communication, because all the services that we consume today, whether you are an individual or you are a business, are all IP based. Like your voice is voice over IP, your video is delivered over IP, your television is delivered over IP, and we refer to that as IP television. Internet, of course, is based on IP. So all the applications, services that you and me consume are predominantly based on IP technology and packet technology. So if you zoom in to the Sri Lankan, specifically the company I represent, SLT Mobitel's history over the last 30 years, it would look something like this. The idea of me presenting this here is actually to show you the type of technologies associated with this time span of almost just over 30 years, and the type of investments a typical telco or typical communication service provider would make over these years. So you have submarine cable systems, you have satellite systems, then you have technologies like, if you can remember, CDMA, which actually expanded the communication facilities to the rural areas, which cannot be covered using wired technologies. Then you have 3G and multiple flavors of 3G technologies, IP television, introduction of IPv6, and then the other advancements, introduction of WiMAX, and very soon introduction of converting WiMAX to LTE and LTE advanced type of wireless fixed and wireless mobile technologies, introduction of fiber to the home and cloud services, LTE Advanced Pro, then submarine cable systems, and other things like data centers, different grades of data centers, submarine cable systems, Wi-Fi, public Wi-Fi, community Wi-Fi type of services, storage as a service, 5G, although in Sri Lanka, as many of you know, the TRC, the regulator, has not yet released the spectrum for commercial use of 5G, but including SLT Mobitel and few others are actually having test 5G sites in multiple places in Sri Lanka. So if you have a 5G capable device, you can actually use that in those locations to experience what 5G really is. And the things like the flavors like the metaverse and the multiple clouds, and also in the business perspective, rather than isolating telecommunication as a business, just confining to telecommunication in the historical value, the telecom operators start partnering with the other ecosystem players like the giant hyperscale cloud players like Google, Amazon, Microsoft, etc., and try to play a significant role or a major role in the large ecosystem of digital infrastructure and digital services. So with all of that, if you really try to understand why telecommunication or why data communication or why digital infrastructure, it actually goes hand in hand with the country's economy. So you can map it to Sri Lankan economy, and this is a kind of a model or an architecture of a digital economy. Everybody talks about digital economy, and certain governments, including the Sri Lankan government, I heard that are working on achieving some of the goals of digital economy. We have a program called DigiEcon 2030, which is also supported by the ICTA and the Computer Society of Sri Lanka. And I hope ISL also has their contributions towards achieving this national objective. But when a country, for very good reasons, try to achieve the idea of a digital economy, what matters for us as telecommunication engineers, and specifically as engineers, is the underlying base or the underlying foundation where this e-commerce, digital solutions, digital content, or whatever the digital things, fintech, like e-health, or whatever the things that you talk about in a digital economy, actually resides on top of a very strong infrastructure or very strong base, a foundation which is actually built out of IT at very high level, which includes hardware and software and telecoms. So you can use a common word called ICT, which actually stands for Information and Communications Technology. So there is an "and" there. So you have both information communication and information technology. So that is why I mentioned over the 170 years, although we still use the word telecommunication, the practice of telecommunication has actually merged with the other disciplines which have been historically named as IT or computer or ICT, data communication, and multiple other terms. But in today's context, it's very difficult for us to distinguish what is exactly telecoms. But the important thing for us here is that the very base is actually built from the idea of telecom and IT and IC. So if you take the ecosystem, we have ecosystems in multiple other areas, multiple other segments. In communication service provider industry, CSP stands for communication service provider. We also have an ecosystem. So this is my way of representing it here. But you could keep the customer in the middle and discuss the other elements of the ecosystem with respect to the customer. But I usually prefer to keep the communication service provider or the traditional telco in the middle and discuss with respect to the telco how the other entities are actually interconnected and interrelated. So we have customers, we have regulators, we have equipment manufacturers, standard developing organizations, and content providers. For example, if you take Sri Lanka, we are regulated by the Telecommunications Regulatory Commission of Sri Lanka, and every country has a regulator. And then we don't manufacture our own equipment. We used to do, like in the days of Bell Labs, like AT&T, they used to manufacture their own switches, but that was a long time ago. But the business has changed now. We don't manufacture our own equipment. We actually depend people like the names I have mentioned here to actually supply us the equipment to build our networks. And standards, like in other engineering practices like civil engineering, mechanical engineering, chemical engineering, production engineering, and all the other engineering practices, standards are heavily used in communications and telecommunications as well. And these standards have also been evolved over the years. Now, for example, the de facto standards that we use in telecommunications, we still use are the ones coming from ITU, International Telecommunications Union, and places like IEEE, the Ethernet standard that we use in telecoms and elsewhere is actually coming from IEEE. 3GPP for all the mobile standards. But later on, we also understand, although not de facto, we use multiple open source community productions, open source tools as standards in telecoms. For example, those who are coming from IT background, you know that to implement cloud native services, we use Kubernetes, and Kubernetes is not coming from ITU. Kubernetes actually comes from the open source community. So standards have also evolved, and rather the way we use standards in telecommunications has also evolved over the years. And telecommunication has expanded out from like not just telephone service, not just internet service, they're expanding to other areas, including, for example, entertainment, like IP television, and if you take other services like gaming, and we have to depend on the content, and content is actually produced by somebody else. And the arrows indicate in this diagram are, for example, the ash color arrow from the CSP to the customer is the kind of services that we offer to the customer. And all the red arrows which are pointed, there's only one arrow pointed to the CSP, which is the revenue that we earn from our customers. And all the outward arrows are the cash outflows from the CSP. For licenses, we have to pay for regulators. For spectrum, we have to pay the regulator. And for equipment, of course, you have to pay. Generally, we don't have to pay for standards, but some standards, yes. And of course, you have to pay for content providers. So this is the ecosystem at a very simplified way, which shows you some of the technical things, some of the business things, and some of the commercial things as well. If you look at the how services and other things are interrelated in a more, I would say, more theoretical aspect, you can envision the same thing I mentioned as equipment manufacturers supply equipment to network operators to build networks, and then network operators provided the services to a service provider. In Sri Lanka, service providers and network providers, or the network operators and service providers, are the same. For example, if you take SLT Mobitel, we are a network operator. We operate a network, and on top of that network, we provide services. So we are a service provider as well. But in some countries, we have network operators who are not providing services on top of their network directly. So say they just run the network, and they just operate the network and provide the network to other service providers for them to provide services to the end users. But in Sri Lanka, all the operators, they run the network, and in that network, they provide services. And then we might use channel partners, the distributors, for example, the people who supply us with the telephone instruments, the routers, etc. So they all build, in a way, a large ecosystem, and sometimes you can envision that also as kind of a supply chain in terms of delivering services to the end user. So if you look at the word network has been used multiple times so far. So if you really look at why a network is necessary, basically we have set of services as a service provider, and we have subscribers, customers, end users, or whatever the name that you use to explain the entity or the person who actually is willing to consume that service at a price. So we have these two ends: the communication service providers or the telcos who are offering the service, and the subscribers, the end users who are expecting or willing to consume that service. So the expectation of a communication service provider is actually to deliver that service to the end user. So that is the objective. And to realize that objective, you need a network, and you call that a communication service provider network, or in simple terms, a telco network. And it is always the case in technology aspect and also in the business aspect. It's because that we want to deliver a service that we build a network and not the other way around. That is, we build a network and then provide services. Of course, that is the case practically, but the initial thing, the logic or the rationale behind a network is actually the service provider's requirement to deliver a service to the end customer. And customers generally, they don't care about networks and they don't buy networks. They buy services, and to enable service providers deliver these services, they need networks. And if you really look at if you really try to expand this cloud, which is a communication service provider network, you will see that you can identify access networks, which are very close to the end users. And then you have aggregation networks, which actually aggregates the traffic coming from access networks. And then you have core networks, something like the superhighways that we have in Sri Lanka, which actually provides a high-speed transport of data from one major city to another major city. So if you take how you build, what sort of media that we use to build this network, we were using a mix of wired and wireless in the past, but most of our core networks, almost all our core networks and the aggregation networks are built out of optical fiber today. So the transport networks, which comes in the domain of core and aggregation, are built out of optical fiber. Because optical fiber by far is the best media that we have today in terms of the distance and also in terms of capacity. But when it comes to the access network, which is the kind of the most spread network in any CSP environment, is always having a mix of technologies or a use of mix of media. For example, we use both wired and wireless media. In wired, we use cables, which is not really used in this part of the world. Cables are mainly used in North America. And then you have optical fiber and the traditional copper wires. So the copper has been initially used for very narrow band applications like 0 to 4 kilohertz voice band being used to provide dial-up internet. Those who are attending today of my age, I'm sure you have used dial-up internet, 56 kilobits per second theoretical speed, but practically you get something like 35 to 40 kilobits per second. But then the same media was reused as broadband. We moved from 4 kilohertz voice band to something like 20 megahertz and 30 megahertz, and started offering services like ADSL, VDSL, and the idea of digital subscriber line born. And some point, those who can remember the Shannon's capacity theorem, you know that the more spectrum you have, the more capacity bits per second that you can have out of any channel. But at some point, we hit the Shannon's capacity limit for copper, and then we had to, of course, change the media. The next media available was optical fiber, and optical fiber can be used in two different flavors, what is called passive optical networks and also active optical networks. The technologies like Metro Ethernet and Carrier Ethernet falls under active optical networks. And for example, SLT Mobitel fiber to the home, which runs today at 300 megabits per second or 1 gigabits per second downlink, works on the technology called GPON, Gigabit Passive Optical Network technology. So that is on the wired side. And if you take the wireless side, we have WLAN, which is Wi-Fi. Then we have WMAN, which is something like WiMAX. But the more importantly, wireless wide area network is actually comprising of the mobile cellular technologies and also the satellite technologies. Mobile cellular technologies start from 2G up to 6G, and so that is one of the major areas in terms of providing access. So the reason why we have a mix of wired and wireless, a mix of copper and fiber, a mix of multiple generations of cellular technologies and a bit of satellite as well, is nothing because when you want to address, like for example, if you take Sri Lanka, we have something like 22.5 million population, maybe 5.5, 5.8 million households, a very different geography, very different terrain. So you cannot go with optical fiber 100% to all the households. Practically, you cannot. So you have to get the help of other technologies like the mobile technologies, wireless technologies, satellite technologies, etc. So that is why we have a mix of media and mix of technologies being used in the access. But when it comes to aggregation and core, which actually provides the transport for all the aggregated traffic which are coming from the access network, is entirely built out of optical fiber. So if you ask this question, where is this telco network today? Also remembering the very history of telecommunication 170 years ago, if you really look at, as I mentioned, this has been evolving over the years and expanding, sort of amalgamating with other areas, other verticals. So today, this network expands from land, which uses optical and copper. On the air, we have mobile and fixed wireless access. Under sea, we use optical fiber because we not just connect within the country, we have telecom networks connecting countries, connecting continents. And then we also have networks in space, like low Earth orbit, medium Earth orbit, and geostationary Earth orbits. We have networks. So telecom networks have come a long way from the traditional two copper wires providing basic telephony service to sort of an omnipresence type of network, which is available in the space, in the air, on the land, and also under the sea. So the same thing is pictorially shown here. So you have satellites, which can provide most of the services today. And you might have heard about the Elon Musk Starlink satellite constellation, which actually works on low Earth orbits. Then you have optical fiber, which sort of build your backbones and also can be used to deliver fiber to the home type of services. Coaxial and hybrid fiber coax and copper wires are slowly getting out of this network and getting out of this business for valid technical reasons, and being taken over by optical fiber. And then you have multiple wireless technologies, and today many talk about 4G and 5G. If you look at the sort of key performance indicators of one of the most important deliveries of telecommunication networks today, which is fixed broadband. The reason why it is called fixed broadband is to distinguish that from mobile broadband. Mobile broadband is nothing but 4G and 5G mobile broadband technologies, which is a huge market in the world. For example, like in the world, there are a lot of 4G and 5G mobile users. Even in Sri Lanka, our mobile penetration is something like 130%. So, but the real challenge for telcos is actually to build this fixed broadband market, and that has been discussed in multiple forums in the world. And you can see, as I mentioned already, if you really consider these indicators like the future-proofness, the cost, speed, and how do you address the rural areas, you can see fiber is not the best choice if you want to access rural areas. Fiber provides you the best speed. It's expensive, but still it doesn't make sense when you want to go to rural areas. If you want to go to rural areas with optical fiber, your cost will be further increased. So the best choice for rural, for example, NBN in Australia, they use something like 2.5% of their connections are on satellite. So that is one of the technologies. And fixed wireless access is actually comes in between of these parameters. And if you look at the infrastructure bills in terms of capital expenditure and the operational expenditure and their lifetimes, some of the things, for example, submarine optical cables, the investments are huge, so many millions of billions of US dollars, but their lifetime goes up to 25 to 30 years. But if you take technologies like terrestrial optical access network, their lifetime is something like 10 to 20 years. Wireless technology is 10 to 20 years. That is the passive side. But if you really take the active elements which are being used to build these networks, like the routers, switches, optical gears, base stations, etc., their lifetime is usually 5 to 10 years. And when it comes to other areas, things might vary. But the idea here is that some of the investments, once made, it will take a long period. And of course, you have to consider that in your calculations. It will take a long period to give you the return on investment. But there are certain other technologies, certain other areas in the network, which has a short lifespan, and then you have to recover your cost within that specific lifetime. So this is very challenging because, for example, a submarine cable system is built for last, for example, 30 years, and it's a huge cost. And once you made that decision and once you invested the money required to build that submarine cable network, there's no way that you can come back. I mean, there's no return. So investment is already done. So you have to be very careful in terms of selecting your investments for all different technologies, all different network types that you want to build. And if you take the total capex of a typical telco, this is based on the Omdia's analysis, you can see the bulk of our investment actually goes to build these access networks. And it is being discussed everywhere in the world, who's going to invest for broadband network expansions? And that is a question being asked in Sri Lanka as well. I mean, if you take a communication service provider, they have to have a business case to go and expand a broadband in a rural village, for example, unless the government should intervene and then provide subsidies and other facilities for them to do like public-private partnerships to build and go expand these networks to underserved or rural areas. So this is very important because the transport networks compared to the access networks is like quarter of that. IT software needed to manage this network again is something like a quarter of that. The cloud hosting data center is less than a quarter of the access network investment. So with this background, we have seen, especially during the last 30 years or maybe the last 20 years, we are going across a transformation or a migration or a rapid evolution of the telco business model and also as the telco technology model. Now, the business model changes from a very basic voice-centric business model to a data-centric business model. I think I need not explain why it is that, because we live in a digital data 1.0 world today. Even our voice is now IP. And for very, very valid reasons, we are moving from wired to wireless networks. Like, for example, if you take India, which has the world's largest population today, 1.5 billion, something like that. They are a mobile-first country. At government level, they have identified that they cannot reach the entire pan-Indian locations with wired or guided media technologies. So they are investing hugely on wireless because wireless, though it's a huge investment, it allows rapid provision of broadband services to the underserved and copper to fiber. And in terms of the networks, we are moving away from legacy technologies like TDM, circuit switching technologies, to NGN, IP, converged type of networks, which actually support packet switching from the access up to the service edges that you have in the service provider's environment. So if you take the evolution of mobile industry, I have actually put a slash or the back slash thing and put wireless there, because one of the distinguished things, one of the things you need to understand, the first 3 generations of mobile technologies are mobile only. If you take 1G, which is analog, 2G, 3G, they are mobile only. But if you take the other 3 mobile technologies, 4G, 5G, and 6G, they are mobile and fixed. So 4G has 2 flavors: 4G fixed, 4G wireless. Sorry, 4G fixed, 4G mobile. Like if you take LTE, TDD is used for fixed, LTE, FDD is used for mobile. In 5G also, we have something called fixed wireless access and 5G mobile. 6G is also same. So although we generally refer to these generations as mobile technology generations, starting from the 4th generation or the 4th 4G, 4G LTE and 5G new radio and 6G technologies, they are fixed and mobile. And if you really look at the type of bandwidth they are capable of delivering, or at least as per the standard, they should be delivering in the range of like 100 megabits per second to 1 terabits per second. So if you map the same thing with the type of bandwidth we try to deliver with optical fiber or fiber to the home technologies, it's more or less the same. So in the last mile, we now have a real competition of technologies, which is wireless versus wired. So we have fiber to the home. At the other end, we have wireless to the home. So, but the challenge here is that any wireless technology to provide a wireless connection, let's say 5G connection at 1 gigabits per second to a household, that 5G base station or the G node B that we have 5G need a fiber connection to backhaul that traffic. So one of the things we need to understand is that when we talk about this massive proliferation of 5G and 6G type of technologies, we really need to have a very robust fiber network which actually supports the backhauling. We refer to the word X-hauling because we have backhaul, mid-haul, and front-hauling of all the mobile technologies. You really need optical fiber to backhaul that huge capacity that is actually coming from the wireless interfaces. And you might have also heard something like private 5G, because when this technology expands, all the wireline networks, regulatory-wise and also business-wise, are actually built by communication service providers. Same for mobile technologies and wireless technologies. They are built by service providers. But for the first time, if you take 5G, 5G networks can also be built by customers, for example, enterprises, because 5G has a very lucrative use case, which is referred to as 5G private networks, which actually allows to replace, for example, Wi-Fi in a factory environment. Of course, Wi-Fi is not used in factory environments because of the interferences, but it is one of the potential technologies that can be used. But 5G is predominantly replacing all the proprietary in-house factory environment wireless technologies using private 5G. For example, in Netherlands, 3.6 gigahertz has been allowed or has been released for enterprises to use private 5G networks. So maybe in the future, Sri Lanka will also have private 5G networks in factories and campus areas for different facilities to provide their own local wireless communication requirements. So if you map the the things that I have mentioned so far, you have the services and the applications. Then you have this session control layer, which actually controls the intelligence of all the controlling of the said networks. Then you have the transport. Transport is actually the core network and the aggregation network. And then you have at the very bottom your access technologies and the access networks. And below that, you have your customers. So customers connect to the access network using multiple technologies. Access networks are always going to be with multiple technologies, will be using multiple media. But the good thing with this NGN reference architecture, or the next generation network concept, is that all the traffic that is being aggregated from the access network comes as IP and Ethernet to the aggregation and core layers. So that allows service providers to actually build a common transport infrastructure, which is the core layer and the aggregation layer. And today, most of the operators use technologies like IP and PLS together with optical communication to build this common packet transport infrastructure. So that is what this NGN reference architecture, those who have heard about NGN next generation network, which actually comes from ITU as one of the standards, if I can remember, Y.2020 or something like that. So it talks about a converged common transport network which supports all the packet and IP based traffic types. So if I am to summarize, by the way, I'm not very good at PowerPoint. So this is my very simple way of trying to summarize all that we discussed so far. So you have the access networks, you have the aggregation network, and you have the core network. I hope now you understand the respective location of these networks, the access network, which is the one closest to the end users, and the aggregation network, which is supposed to aggregate all the traffic coming from access networks, and then hand over to the core network, which does the city to city superhighway type of transport of traffic. So I divide this network into two areas. One is wired, the other type is wireless. Wired has, for example, copper DSL type of services, fiber passive optical type of services, a combination of DSL and fiber, active optical networks like Metro Ethernet and copper carrier Ethernet, which generally provide services to enterprises. And all this traffic coming from all these access networks are actually aggregated on the aggregation network using a technology called carrier Ethernet. It is a bit different from the traditional Ethernet that we use in local area networks. Carrier Ethernet is a carrier grade kind of hardened Ethernet technology that we used in these type of environments. And then that traffic is handed over to the core network. The core network can generally build out of fully meshed type of connectivity, can transport traffic from example, Kandy to Colombo, Jaffna to Colombo, Colombo to Galle at very high speed. And if you look at the wireless side of the affairs, you have Node Bs, which is the base station for LTE, 3G. And then you have E-Node Bs, which is the base station for LTE. And then you have E-Node B two flavors. One is fixed, one is mobile. As I mentioned, LTE can be fixed LTE or mobile LTE. Then you have, for example, we had WiMAX as a technology, but WiMAX was later converted to LTE. So these are some of the technologies. Now, I have not shown 2G here, although I have shown 3G in the form of Node B. One of the things about 3G and 4G is that they both require, to a certain extent, TDM infrastructure to backhaul their traffic. For example, 2G requires E1s, TDM circuits to backhaul the base station, and 3G requires IMA E1s or inverse multiplex over ATM type of E1s to backhaul. But there are certain other techniques to convert the TDM payloads to Ethernet at the cell site, and avoid service providers building dedicated TDM infrastructure to backhaul 2G and 3G traffic. So, but in the future, the network is going to be entirely packet based. And another demarcation is to understand what is the difference between fixed broadband, if you consider the consumer internet services, and what is referred to as mobile broadband. So wireless could be fixed or mobile. Mobile is always wireless. I hope you got that, right? Mobile is always wireless. There's no doubt about that. But everything wireless is not mobile. So we have fixed wireless access, which actually provides, for example, a kind of a wireless point-to-point connection to a business or a household. So this is basically at very high level what we have today. And these networks, which have been discussed in a context more technical in the past, are now being discussed in a more commercial and business aspect in our community. For example, networks are now being envisioned to look at in two different flavors. This is actually related to the data communication, and that is why I wanted to build this discussion starting from telecommunication to data communication, and how this digital ones and zeros and data communication, IP and packet networks are actually changing the way we do telecommunication operations, and also we do telecommunication business today. So we have content to content networks, the networks which are built to connect the data centers, like data center to data center connectivity, which is also referred to as DCI, data center interconnections. And most of the investments in today's telco segment are actually made on DC to DC content connections. It may not be the case in our part of the world, but rest of the world, most of the investment are on DC to DC, because most of the traffic are now being transferred between data center to data center, because whether it is a consumer, whether it is a business, government, enterprise, everybody works on the cloud, or they are hosting their data, processing their data inside a cloud environment. So most of the traffic, although we actually get the outcome of our computation, outcome of our processing to a device that we may be holding in our hands, all the traffic type and processing happens most of the time between data centers and data centers. And then how you get the result out of your cloud operations. For example, you run a artificial intelligence workload using a machine learning algorithm in one of the super high computers in a cloud data center, but then you want to get the result, let's say, to your laptop. Then you need an access network. So that is called the content to user network, or an access network, which is today built mostly using broadband technologies. Broadband stands for high speed internet connectivity. In general, we have something like 20 to 30% increase or growth of traffic, whether it is fixed or mobile. So it's a very data hungry network or a requirement that is being imposed on the telecommunication service provider side in terms of technology and in terms of investments. So if you really take the type of assets that we hold as telcos, one of the biggest assets of a telco today, apart from the workforce, which is actually the biggest and the most valuable asset any organization has, the people in that organization. But after that, maybe next to the buildings, we have the fiber, which actually provides bit transport. Then you have your data centers, which actually does the bit processing and bit storage. So if you really look at the modern history of telecommunication, which is actually starting with the inception of data communication, we talk about only three things. It's very simple. One is bit processing. The second one is bit storage or byte storage. The third one is bit transport. So we do only three things. And usually the bit processing and bit storage is taken together. And that is where you talk about data centers. And the bit transport is your network, which includes your access network and the transport network. So that is basically, if you really want to look at this telecommunication industry and the telecommunication business at let's say 30,000 feet helicopter view or 30,000 feet aeroplane view, you will see a set of data centers connected over a fabric of fiber networks, and also end users accessing the resources in these data centers using multiple broadband access technologies. And apart from this two, the third most important thing which actually came into picture in the very recent years, like in the last 10 years, is energy and the power. You need huge amount of power to run data centers, and it is ever increasing. And also you need power to run your transport networks. For example, if you take fiber assets, the utilization may be less, but if you have a neutral carrier, for example, in UK, BT has a neutral company called Openreach, which provides neutral carrier access to anybody who wants last mile connectivity on optical fiber and copper, which makes your asset utilization higher. And then you have certain tech transformations, new technologies. And if you take the competition, it could be like you can compete as service providers in an urban area. But when it comes to rural, together with the governments and the communication service provider regulators, it could be like just one operator providing services in rural areas. Because it doesn't make economical sense for anybody to go and compete in a rural area. It's rather beneficial for everyone to select your area, and I go and build in this area and I go and build in that area. So that is kind of a practice most of the countries adopt to address to deliver services to underserved people. And people ask, what is the killer app for AI? For me, the killer app for artificial intelligence is the data center, because you talk about all these artificial intelligence and machine learning algorithm and large language models and whatnot. All these need computing power to do this computation. So data center for me is the killer application of artificial intelligence, and that is why the companies like NVIDIA, Microsoft, Intel, they are actually building all these GPUs and stuff, which actually goes and reside in one of their data centers. Of course, artificial intelligence need data center, because data center is the place where your artificial intelligence is actually residing. And to access your artificial intelligence, you need fiber. So you can basically summarize it in that level. And one of the things you might have heard in general discussions is that the telcos always say, we don't want to be a dumb pipe. So it's actually a dumb statement. The telcos provided connections are not pipes, right? The telecom networks are actually infrastructure. So as engineers, I hope you understand what is an infrastructure and what is not an infrastructure. For example, the bridges, dams, railroads, airports, highways, they are infrastructure. So is telecom networks. So it's very important that we understand telecom networks in that way, rather than the pipe providers, or sometimes referred to as dumb pipes, to provide just a transport of bits and bytes. With all of that, we have only managed to provide services to only 2/3 of the global population. Out of nearly 7.8 billion today, 1/3, 2.6 billion is still not connected. And it varies. For example, if you take Asia Pacific, that number is something like 56%. but if you take Europe, it is 91%. And it also goes with income. If you are a low income country, your value is something like 27%. But if you are a high income economy, that is 93%. So if you take the average revenue per user in Sri Lanka is something like $2. In India, it is something like $1. And that is one of the reasons, as I mentioned, India is not looking at fiber to the home type of services at mass scale. In a market which is around $1, you really need to go a mobile first strategy to reach that market. Sri Lanka also needs to consider these aspects when investing on mobile technologies and broadband technologies. So another thing is what should take priority over. For example, everybody talks about 5G. Of course, in a way, 5G is a marketing thing, but it is also technological evolutionary thing, next step after 4G. So you have to make your investments. But there are, even if we go for 5G, there will be some not spots. Of course, in townships, we have hot spots, but in rural and suburban or urban, not suburban, rural and remote areas, we have not spots where you don't get any signal, any coverage. So you have to select where should my investment goes. I mean, it's not a simple decision because the rural is a not spot and not covered, but if you make the investment, can you get the return on investment? On the other hand, urban is side of congested. If you really invest in the urban, how I'm going to get my return on investment in a competitive business environment? If you look at the satellite side of the affairs, you can see we have geostationary satellites, which are great. So Arthur C. Clarke mentioned that with 3 satellites, you can cover the entire globe. But these satellites are far away from the Earth's surface, something like 36 kilometers. And then you have medium Earth orbits. You generally need like 6 satellites to cover 96% of the Earth's surface. But they are also far away, like 8,000 kilometers. But then you have low Earth orbit, like the Starlinks and like AWS project Kuiper. Those satellite constellations come in something like less than 1,000 kilometers. Why the distance is important? Most of today's applications, sometimes some of the applications require low latency, like what sort of delay that it will take for me to go from the Earth's surface to the satellite and then come back. So low Earth orbit provides you something like 50 millisecond latency. It's wrong here. It's not meters per second, but it's milliseconds. Medium Earth orbit is 150 millisecond, whereas geo is 700 millisecond. So there are certain challenges there, but telcos are hugely investing in satellite communication technologies as well. And satellite could be one of the big things in years to come for telcos as well. And we can have cell phone networks on the space as per Starlink. And even people like Rivada Space Networks, they're talking about building the entire IP MPLS backbone networks on the air. So rather than building your networks connecting optical fiber, why not build the entire transport network on the air using point-to-point lasers, which they say is a very reliable network, because the light in optical fiber travels as 200,000 kilometers per hour, but the speed of light in a vacuum is something like 300 kilometers per hour. So what you have in the space is kind of a vacuum. So you have higher speeds, and also reliability wise, you don't get with all due respect to my colleagues in waterboard and CB, you sometimes go and dig a trench and then you damage the optical cable. sometimes we go and ditch a trend and we break a what do you call a water pipe. So we don't have these issues in the space. So that is why they are suggesting that why not build this type of a network on the air, which is very reliable in terms of connectivity. And this statement, few years, I think a couple of years back from Nick, who is the CEO of TM Forum, what he said, you have to read this very carefully. Telco collective investments of about $1 trillion in the last 5 years have brought merely, there's a spelling mistake there, return of less than 1%. So you invest $1 trillion in telecoms and your return is less than 1%. So why you have to be careful in reading the statement is that some of these investments are not expected to give the return within 5 years. For example, this 1 trillion might include submarine cable investment, satellites constellation investments, maybe domestic fiber-based investment. So those investments will not give you a return on investment within 5 years. But at very high level, it also gives some sort of an indication that this industry very much is CapEx incentive. You have to invest a lot. The only problem is how do you make your investments carefully. And the other problem affecting us in telecoms and also maybe the other disciplines of engineering is this deglobalization. So while ago we talked about globalization, like few decades of years ago, we said we are a globalization, this is a global village, we are getting closer, which was good. But then recently we have these geopolitics, especially the Chinese and the Russian, and their acts sometimes result what you refer to as deglobalization. And this affects, especially we saw when the US and China has their own issues with the technologies and geopolitical things, how it affects the entire supply chain of telecoms. Because like most of the telecom stuff are actually manufactured in these cheaper labor markets like China. And we might have the top brands like Cisco, Juniper coming from United States, but their manufacturing is done in China. So are we to outsource that manufacturing to other countries, or are we to have a better geopolitical understanding between the countries is also something that we need to be care of if you are a telecommunications engineer. So what are the major challenges in terms of addressing some of the things I mentioned in developing economies like ours, emerging and developing economies? One of the things, even with the higher literacy rate that we always boast about, one of the major challenges that we identify in developing economies everywhere in the world, the first one is education, the second one is power. The power, of course, is a huge problem for the telco industry and the investors who want to invest in the telecommunication industry, for example, the data centers, etc. So power is a huge problem. Education is also a problem. For example, that also goes with the country's economy. Now, there are stories coming from South African countries, not South Africa, other South African countries. When you go and put up base stations, people actually dismantle the base station and sell the tower for iron to earn money. So you need to educate people why the base stations are there, what sort of thing that you get, what are the benefits. If you have the connectivity, you can do financial activities over the mobile technologies. You can do, you can get health services. You can get benefited for your agriculture, etc. You need to educate them. Luckily, we don't have that type of situations in Sri Lanka, but education is largely considered a factor that is mostly affecting developing economies. So in these African countries, they actually had to put a security guard. Actually, South African countries had security guards to protect these white rhinos, but now they are actually protecting their base stations, the towers, like they are protecting the white rhinos. So an example how a government and a regulator can support while addressing the challenges that I mentioned, how could one support the investors who are willing to invest in telecommunication, the modern telecommunication? Now, Ashburn in Virginia in US is considered the data center capital in the world. Most of the hyperscale companies, they have set up their data centers in Ashburn. Why Ashburn? Is because the cost of land in Ashburn is low. Cost of electricity is 20% cheaper than the natural average in the United States. Ashburn traffic is 70% the world's internet traffic flows through Ashburn, and the local government tax cuts and incentives. So this is an example how the federal government or a state government or a county government can, local government can support the ICT investments in terms of the cost, in terms of capital cost, in terms of operational cost, etc. And as we move forward, we understand that telecommunication is not just about networks. Networks is also a very important part of telecommunication, but data centers are now becoming a very important, equally important part of telecommunication. And how do we measure the size of a data center? We used to measure the size of a data center using number of racks or the amount of square feet that it takes. But now, today, for very valid reasons, we measure the size of a data center using the amount of power the data center consumes in terms of megawatts. For example, if you take a typical hyperscaler data center, they start at least 40 megawatts of power. So that is why we don't have hyperscalers in Sri Lanka. For example, we don't have Meta, we don't have Alphabet, we don't have Microsoft, we don't have Alibaba, Tencent, or anybody investing to build a data center in Sri Lanka, because they at least need 40 megawatts of power. At least they have to build their own power plant, or they need an assurance that the grid can actually provide 40 megawatts of power. And the biggest problem is not just power, how efficiently that we consume power to run our workloads inside a data center. So you have this power usage effectiveness. Out of the total IT equipment energy, if you divide the total facility energy, the amount of energy the grid supplies to the building, and divide that with the IT workload, it is something always greater than 1. I don't think we can make it 1, because there always will be certain losses, but you need to make it closer to 1 to make the power effectiveness. So it is something that we need to work with our electrical engineering colleagues to build these data centers power efficient. And people are also looking at the nuclear as a power, because nuclear sometimes is scary, but not large conventional reactors, something like 700 megawatts, or small modular reactors, something like 300 megawatts, or micro reactors, which works something like 10 megawatts. So we have nuclear fission versus nuclear fusion. Nuclear fusion is kind of very safe way of generating energy. And I believe in the future, we have these small micro reactors or modular reactors, which works on the technologies like nuclear fusion, being used to generate power or energy for the data centers. And another thing we see in this industry, this is just an example what happened to VMware. Those who know, VMware is one of the platforms that we use as a hypervisor in our data centers. They started their business in 1998, and EMC acquired VMware, then VMware acquired Nicira, VMware acquired AirWatch, then Dell Computers acquired VMware in 2015. Then Dell and VMware together acquired Pivotal and Carbon Black. And then in 2021, VMware became independent because they disjointed from Dell in 2021. In 2023, last year, Broadcom acquired VMware. And very soon you will see Juniper Networks acquired by HPE or HP Enterprise. So the markets are sometimes expanding, sometimes shrinking, but going forward, we see most of the markets in terms of vendors, they're actually shrinking, and the larger ones try to get the kind of monopoly in these supply chains. As I already mentioned, talent is going to be one of the biggest challenges in ICTs. And it is also the number one is investment for any telco or any company for that matter. And those who are seeking opportunities in this space, I have another webinar tomorrow afternoon for advanced level students where I'm trying to discuss what sort of opportunities that are there in the world and how they should gear themselves to capture those opportunities and to support the Sri Lankan economy to get to the level that we all expect. Now, this is from India. Actually, they have a huge problem. As you know, Jio being the largest mobile operator in India, they have something like 450 million mobile subscribers, including 4G and 5G. They have a huge issue with 5G talent. Now, will we not have the same challenge in Sri Lanka when we sort of build our 5G networks maybe next year or after next year? So how do we make sure that we have the right talent, not just for 5G? How about artificial intelligence? How about blockchain? How about cloud and cloud native technologies? We have enough talent for networks, because networks is the first thing we did in telecommunications. It's a very mature practice in telecommunication. Data centers to a certain extent, yes. So that is basically your transport and your hardware. But all the things coming today are built on top of that infrastructure, like artificial intelligence, blockchain, cloud and cloud native are actually built on top of that, what you call the so-called hardware infrastructure. So this is one of the areas that is related to this. The biggest challenge is the talent. And if you do the right investments, it's a big opportunity for you. And how about security? Now, one of the things about telecommunication is that undoubtedly we are moving from circuit switch to packet switch. Everything is IP today. When I say IP, it may not be private IP. It could be public IP also. Some of our services go through the public internet. And how about security? Now, what this source predicts is that the cybersecurity market global forecast from 2023, which is $190 billion US, will become almost $300 billion US in 2028. So like 9.5% increase from 2023 to 2028. And of course, we are now in 2025. And see Asia Pacific, the opportunity that we have in Asia Pacific. I'm just trying to relate just one example of the talent. The market requirement or supply versus demand, if you take. This is the demand. And do we have the supply? Do our education system has the supply to address this requirement? You can see from 2023 to the 2025, the amount of investments, market size that is going to increase inside the security front. And this is a kind of now whether we like it or not, we are now in a very rapidly moving kind of a rat race in terms of technology, in terms of business, in terms of economy, in terms of talent. We are moving at a very, very fast pace, and technology adoption, knowledge adoption, all of that. So once in a while, a new technology or technologies will come, for example, artificial intelligence. It could be artificial intelligence, it could be blockchain, it could be cloud native, it could be 5G, 6G, etc. And there will be few other new technologies coming in the future. One thing is about the promotion and the marketing of that technology. For example, 5G, what Mobile World Congress is all about is marketing 5G and artificial intelligence. And then the second most important thing is, how do you regulate this? How do you put the rules to regulate these new technologies? In most of the economies, for example, especially the developing and the emerging economies, we don't see enough regulation rules being discussed, rules being introduced to actually to regulate these new technologies. So it's very important. Otherwise, everybody will be carried away with the top one, which is the promotion and marketing of the technology, and ultimately realizing that we are actually not getting anything out of that technology, although we have made certain investments on those technologies. So AI is something that will play a huge role in telecommunications as well. We have public AI, for example, ChatGPT, if you take, which requires high GPU, which means high power. And then you have private AI, the small AI applications run in your mobile phone, your laptop, runs on low GPU environment, which requires low power. So the equation is actually, if you need more AI, you need more GPUs. More GPUs means power and cooling. That means more energy. So AI basically is about energy. So if you invest $1 on a GPU for your AI applications, you have to invest another $1 for your energy. So that is why regulation is also important, and to select AI to the places where it actually matters the most. And the impact of AI, not necessarily in telecoms. For example, I was in US a couple of weeks back for a conference, and I did not have to use my passport at the border crossings in the major US airports. So it was all face recognition. They recognized my face even to board an airplane, customs, immigration. It's just a matter of using your face to detect who you are. So there are positives, there are negatives. In telecoms, there are more positives. In artificial intelligence, we can do a lot of things, especially analyze network data, customer data, traffic data, and to do better outcomes, do better predictions in terms of telecoms and technology. And we don't have to really be scared of AI as such also, because as per Gartner, some of the things will be entirely done by human beings. Some of the things will be coexist, artificial intelligence and the natural intelligence, but some of the things will be entirely done by artificial intelligence. For example, weather prediction will be entirely done by artificial intelligence. Personal care therapy will be entirely done by human performance. And there are people always who support AI, the boomers, and the ones who do not support AI, the doomers. So it is always the case for any new technology. But for telecom, as per my experience in the last 2 decades, what I see is that telecom can have better outcomes by using artificial intelligence. It is predicted that it is going to be a $300 billion opportunity for telecoms alone. AI. So it's a huge thing. I think it's very much bigger than almost of the size of the entire cybersecurity market size that we predict in 2028. And these are some of the things you already know and you already associate in day-to-day basis, like ChatGPT or is OpenAI is the most used, most visited AI tool in the world. And there are other things as well. And if you take blockchain, we are using blockchain in telecoms as well. There are private blockchains, for example, Walmart uses IBM Hyperledger in their Walmart stores. And then you have public blockchains like Bitcoin and all the other cryptocurrencies. But there are certain applications of blockchain in telecoms as well. So with all of that background, if you really look at the telco business model or the telco business problem, it is something like this. If you really map the timeline that we mentioned, up to 1990, it was the voice dominant business era. Everybody was happy. Like per minute, we charge a huge amount of money for a voice minute in those days. But when things were deregulated in 1990, we started the data dominant business era. Things started changing. The traffics are increasing. To build the networks and the systems to support that traffic. By the way, when I say traffic, it includes the traffic which is on the move, which is your bits per second transported, and the traffic which is stationary, which is your bytes stored in your data centers. So to build your networks and the data centers, you have to invest and your cost is increasing. At the same time, as telcos or communication service providers, you see that your revenues are not increasing the way you want. The revenues are increasing, but not compared to the amount of investments that you make on building those capabilities that are required to provide these services. And if you take the number of customers, most of the markets, the customers are kind of stagnated. Now in Sri Lanka for the last 5 years, the customer base for mobile is something like 130%. Fixed customers are not growing the way we want. So that creates what you refer to as in the industry as the decoupling of network traffic and the operator revenue. So as engineers, as professionals, our duty today and tomorrow is going to be like mathematically, how do you close this gap? One thing is you need to bring the cost curve down, or you need to increase your revenue curve up, or do both. Generally, we need to do both. But how do you do it? So that is why the telecommunication needs to transform to address the modern changes which are imposed on us by the external environment. So things like automation, virtualization, development operations, which is mainly coming from the IT side and software side, we need to bring those capabilities and the know-how to telco business models. At the same time, we need to be more agile and flexible in terms of doing things, and the software way of thinking and software way of doing things will actually help us to be more agile and flexible. So we need to think like a software company. Though we are a telco, we need to start thinking like a software company to address this problem. So we are moving from a monopoly to a more deregulated market. The markets are getting more competitive every day. So we have to be quick. You have to take decisions. You need talent. You need people to do these things. So it's a huge problem, or huge problem at hand for the telecom engineers to address these things. In terms of trends, we will see that in the future there will be more things added to this list, and some things will vanish from this list. But this is the rapid change of telecommunication and technology. So I have already mentioned some of these words. And the other thing we see is that some of these things are actually coming from our vertical industries. So we talk about health in telecoms, We talk about finance in telecoms. We talk about vehicles and mobility in telecoms. We talk about mining, maybe oil and gas in telecoms. So telecoms is not just a one isolated industry anymore. So we have to work in partnership with some of the vertical industries that we have in the larger ecosystem. So the transformation, whether you call it a digital transformation or cloud native transformation or whatever the transformation, is actually imperative for us. So I'm not going to mention from where to where you go, because some say it is CSP to DSP, some say it is telco to techco, some say it is service provider to experience provider. But the fact is that we need to change as an industry, and we are already changing, and we are in the middle of changing. For example, we are moving away from the traditional networks mindset to a more like a full stack platform mindset. When I say full stack, it's not the software stack, but when I say full stack, I mean from the physical connectivity, like layer 0 up to the highest level of your applications. Consider that as a platform, not just as a network. Moving away from hardware mindset to a software mindset and a more cloud native mindset going forward. And the type of network, some of the names we already mentioned, like next generation network, to a software generation network, which is a virtualized version of the next generation network, and to a telco cloud. Some of the technologies we talked about, like TDM, Ethernet, and softwareization cloudification, it's not going to introduce any new technologies to packet transport. We will still use IP and Ethernet in softwareized and cloudified environments, but it's a different way of doing things while actually respecting the first principles of our communication. In this way, we are actually moving away from this CapEx and asset heavy business model, which we are today, to a more OpEx and CapEx light business model. That doesn't mean that we are going to get rid of all our hardware assets, like our towers, the fiber networks, the submarine networks, the data center buildings. Not that. Most of the telcos are looking at delayering their assets. For example, focusing more on the services and let someone else to do the network, and focus on the network and let someone else to do the services. So these type of business models are being introduced into the telco domain as well. So one of the things here about softwareization is actually a name coined by IEEE a few years back. It talks about three different concepts. One is software-defined networking, how to softwareize and abstract the network capabilities onto software. Network functions virtualization, or NFV, decoupling your functionality from the location, allowing you to run your network applications on a commercial off-the-shelf hardware rather than relying on a dedicated supplier to supply you with a dedicated hardware to run network applications. And then the cloud, which actually coming from the IT world, which decouples the infrastructure from the applications. Like you can run any of your applications, not the network functions, the applications on any server, any x86 or any type of server in a typical data center. So when you combine all these three dimensions, SDN, NFV, and cloud together, then we have something called the softwareization. It's not just thinking like software company, practicing software coding, software programming, software algorithms like that, but it's a full combination of software being used in a telecom environment, and that is really mean by what is really mean by softwareization. And when you say telco softwareization, we extend that from general practice of softwareization to another level where we bring in the other technologies that I mentioned, these technologies. So we bring in not just SDN, NFV, cloud and cloud native, but we bring in, for example, blockchain here, we bring in AI here, several other things. And all these several other things I mentioned, all the dots after the plus sign after the cloud, are going to be software tools or the software application tools. So basically what we are going to have is abstract the entire hardware capabilities that we have, whether it is in terms of networks or the data centers or something else, abstract those capabilities to a software layer, and then use the software more often to actually to control your hardware and to support the applications running on top of the software layer. So that is the idea of telco softwareization. So in that type of a situation, you will find yourself more like what in the external world. Of course, I'm not on Instagram, but how do you showcase yourself generally using social media like Instagram, Facebook? The Instagram for software developers is GitHub. So those who are coming from software background, you see that you can have your codes, whether it is open source or not, on the GitHub, not just as individuals, but as companies also. So GitHub is going to be the Instagram for the developers, whether you are an individual or a company. And then we are running into our last 10-15 minutes. So I just wanted to touch something about the TechCos as well. So we have this word, or rather the phrase telco to techco. Who is a telco? So in terms of, if you just compare, this is from STL Partners, a very reliable agency who's supporting the industry with their analysis. All the red dots you see in this red dots, or the red circles that you see on this graph, are actually the telcos. So they are called the mode builders, or they build things expending huge capital investments, and they don't spend much on research and development. You see, their research and development out of their revenue is less than 5%, or sometimes 3%. Even the larger telcos, like the names of Deutsche Telekom, Singtel, AT&T, Telefonica, China Mobile, less than 3% of their revenue goes to R&D. And how about capital expenditure out of their revenue? Over 10% of their capital expenditure, over 10% of their revenue goes as capital expenditure. For example, for China Mobile, it is almost quarter of their revenue goes as capital expenditure. So that is why we call telcos are more capex heavy business models. But if you take the traditional techcos, like of the Apples, the Amazons, the Alphabet, Facebook or Meta, Intel, Ericsson, Cisco, they generally spend something like 10% to 25%. Look at Qualcomm, they spend quarter of their revenue on R&D. And their capital expenditure on revenue is very less. For example, even Facebook spends like less than 20% of their revenue on capex. If you take Qualcomm, it's around 5% of their revenue is spent on capital investment. So they are very much capex light business models. So when you say you want to become a techco, you have to really define what you really mean by a telco techco, right? So when you say you want to become a techco, do you mean you want to become something like Meta, or you want to become something like Alphabet or Microsoft, or you have your own version of definition for your telco techco? And most of the techcos who refer themselves to as techcos in the telco field are actually doing revenue diversification. So that is what really meant by a techco in the telecom field. If you take SoftBank in Japan, Turkcell in Turkey, KDDI in Japan, SK Telecom in South Korea, TELUS, I think in Canada or Europe, Singtel in Singapore, they get something like 30% of their revenue from non-traditional businesses. Like connectivity is your traditional business as a telco. So if you can get something like 30% of your total revenue using non-traditional telco practices, then they refer themselves to as techcos. So I think in a way it is okay, but I still doubt why do they want to call them as techcos, whereas techcos operate in a different business environment. I think this is my last couple of slides, maybe. Yes. So why it is challenging for us as telcos? Because this is AWS. These are their products. They are one of the techcos, and see what are the things they do not offer compared to what a telco offers. For example, they have their own satellites as well. Project Kuiper is their low Earth orbit satellite constellation. So they're doing all these things because of they have the agility, flexibility, being a software first company. Their mindset is software first, their technology is software first, their work practices are software first. So that is why software is more important, and most of these techcos that you saw here are actually using software to do almost all the things. Their dependency on hardware is very minimal. So what we need to do as an industry? So one thing is, over time, we are an industry already 170 years old. We have certain ups and downs over the last 170 years, especially during the last 30 years. If you take the innovation, like if you start it from the 1876, where we innovated the telephone, we had times, as I mentioned, AT&T used to build their own switches. We at sometimes use the PST and class 4, class 5 switches manufactured by AT&T. So they built networks, they built network equipment, and they provided services. So that was like hundreds of years ago. But at some point, this ecosystem started seeing somebody called vendors, and they start innovating on the likes of Huawei, Cisco's, Juniper's, ZTE's, Nokia's. They start building these equipment themselves. So at some point, in terms of innovation, we saw that they overpassed us in terms of innovation. They did all the engineering, product design, product implementation, whereas telcos were pushed to do operation and maintenance and provide services. Initial focus, as I said, was on hardware, but the future focus and the current focus is software and also cloud native type of technologies, where we are somewhere here today, where the innovation is not very much considered a telco thing, but innovation for telco actually happens outside telco. But the industry and the telcos have realized this, and it is going to change in the future. So in the future, we will do better, I hope, and do co-innovations between not just with vendors, the standard developing organizations, the universities, research organizations, the institutions like IESL. The telco industry will work together with all these ecosystem partners to co-innovate and get back to the innovation again. So without getting into innovation, without spending much on research and development, with all the challenges that we have in talent, we are not going to win this race as an industry. So I want to leave this with you for you to think what has happened. By the way, this in a nutshell summarizes, we are very much used to sinusoidal waves. This summarizes the frequency and impact of business disruption. It also, you can replace business with technology. So frequency and impact of business or technology disruption. What we have today is the light blue sinusoidal curve. The impact is low, the frequency is low. We can sort of cope up with the type of changes that are happening. But the future sinusoidal wave, which is on the dark blue color, is having high amplitude, meaning that the impact is high, the frequency is also high. So things going to change quite fast, and those who have tracked this industry for the last several years might have noticed that new technologies come at a very faster rate, and they are going to create lasting impacts on the telecommunication industry and also on the society at large. So higher impacts at a higher frequency. Are we ready as individuals and professionals or economies or nations and governments as industries? Are we ready to cope up with these type of changes? So with that, I wrap up my kind of 2 hours overview on future telecommunications on the business and technology aspect. Anyone who wants to reach me, these are my contacts. I am on email, LinkedIn, X, and there's a YouTube channel for knowledge sharing. I'm not on any other social media. If you have any questions, I'm sorry, we have just 5 minutes. We can take any questions. Any questions? You can use the chat if you want. Are you there? Yes, Engineer Jayant Ranatunga, you can ask a question. Engineer Ranatunga, you can ask your question. Do I need to unmute you to ask the question?
No. Hello, can you hear me?
Yes, I can.
Right. Looks like for Sri Lanka, our power situation seems to be the biggest drawback for our future in telecom, as you have mentioned. Is that correct?
It is going to be one of the biggest problems. Other than the economic situation, power is going to be on one side, the amount of power we are going to consume in a modern telecommunication world where we have more data being residing on data centers and more artificial intelligence type workloads being run on these data centers using high power requiring GPUs. And on the other side, the amount of power needed to cool these data centers. So yes, it is going to be one of the problems. And if you really do not address that, not just for telecommunication, but for other industries as well, if the government do not take the high level view and take the overall cost benefit analysis on maybe subsidizing like the countries like Bangladesh, Vietnam, and other countries do to attract the manufacturing to their cheap labor markets by subsidizing energy prices, but then getting it back from the foreign direct investments and other stuff. If you really don't have that type of strategy, I think we're going to have a problem. Yes.
Yeah. Well, if that is the case, I think you should be speaking to the policy planners, because I have never heard our policy planners thinking the telecom industry or service industries as big power consumers. They always think that it is the industry and the other, the general purpose sector. But it looks like telecommunication also is a very large power user, as you have been mentioning. So
yes,
why not our policy makers take cognition of that fact?
Yes, it's not just telecommunication, but I take telecommunication and technology together. For example, if we really want somebody like Meta or Alphabet or Microsoft or Alibaba or Tencent for that matter to come and invest on a regional hub data center in Sri Lanka, they need something like 40 megawatts of power. So that gives you some sort of indication the type of investment that we want as a low economic developing country, and how do you actually facilitate that type of investments, and power is going to be a big problem there.
Yeah, okay, thank you.
No problem. Any other questions? You can use the chat facility also in Zoom to ask any questions.
So, if there are no any question from the audience, I think we can have this session. Are
Okay.
there any questions from the audience? Otherwise, let me deliver the vote of thanks speech on behalf of the sectional committee. Ladies and gentlemen, we have come to an end of another very informative webinar on future of telecommunication, navigating the Techno-Business advancement by our esteemed speaker, Engineer Anuradha Udunuvara. As we navigate the ever-evolving landscape of telecommunications, the insights gained from this webinar will undoubtedly serve as a compass guiding us throughout the complexities and innovations that lie ahead. Dear Engineer Anuradha, thank you so much for sharing your valuable insights with us throughout this period. As always, you are a very resourceful person to the ISL and the telco industry. Again, thank you very much for making this webinar an enriching and memorable experience. And I would like to express a special thanks to the organization committee and the participants who made this event a success. In closing, I would like to express my anticipation for future events and the continued exploration of groundbreaking ideas. Everyone, good evening and have a great day.